Hey, welcome again. I'm going to record second problem today. So this is in my series. See, draw. Okay, in my series of MCAT and JEE prep. And right now we are doing F equals MA problems. Okay, so this again comes from Kleppner, Co. book. So here is a interesting problem, and there's no numbers here. Of course, you can put numbers and make the simple numerical values, but actually you will lose the concept. I want you to be focused on understanding it, not just get the answer. All right. So here's a disk which is rotating, and you have a mass here, a block here, and a block here. Okay. And there's a string that's connecting, and something is holding it here. So there may be a tension in this side is string TB, and this side is string TA. Okay. So at t less than 0, this is rotating, somebody is holding, it's a catch, and because of catch, tensions can be different. Okay. And I let go of catch, then it becomes one string, and tension has to be same, right? So that's the problem here. Is so if I go t less than 0 situation is TA doesn't have T equal to TV, and you can actually tell it has to be different because if this is going in a circular motion, so let's look at that situation. TB has to be MB VB square over R, and VV equals to omega RB. So MB omega square RB. So that's the tension on this side. And tension on the A side, you're going to go exactly same way. MA omega square RA. And depending on what masses are, they can be different. So TA doesn't have to equal to TV. And this is the situation for T less than 0. Now, when you let go of the catch, these guys can slide around and adjust such that the tension here will become same. So we'll T greater than 0, TA equals to TB, let's call it common T. So having understood the situation there, we're supposed to do at T equal to 0, the catch is removed, the mass of your slide, and find this, what that is. That is d square R dt square, and R is radial coordinate of polar coordinates. So basically what's going on is, so this is the x-axis and this is the y-axis, and this distance is RB and this distance is RA, and this will be theta B and this will be theta A. So those will be polar coordinates. And it's saying, don't worry about the angle part, just the radial part for the A, this should be capital A. And you get your answer in terms of mass 1, mass of the second guy, and the length of this whole thing is L. L of the string, how far A is, and immediately after. So RA 0, that's what that is, t equal to 0, and omega. Okay, so at t it was RA, this was just given at RA. Okay, so what we're going to do, well, we're going to write these same equations and make them equal to each other, right? And from there we can get that. So let's write the equation for, so what is F equals to MA in polar coordinates. Okay, all right. So, and we can look at t equal to 0 plus. So F on A, mass of A, let's see writing A. So what's an acceleration in polar coordinate? Polar coordinate is, let's do dot for d dt and double dot for d square dt square. This is going to simplify a lot of writing. So it's r double dot minus the theta dot is omega, and theta double dot will be just omega dot. So we're going to angle variables like that. Omega is square theta. So this is the centripetal acceleration in the r hat direction, plus theta double dot plus 2 times r dot, and this is r theta double dot. So this one I would recommend memorize it if you find polar coordinate a very useful tool. Okay, so looking at this is going to be 0 because omega is rotating at the constant thing. So this will be omega is a constant here. So when the this will be 0. So there will be these guys. So acceleration will be that guy, but okay, so that's no problem. So you got a acceleration like that. So just look at the radial part. So this will be, if I look at the tension, will be that way towards the center, this particle A, and r hat is that way. So writing the equation, just the radial part, r hat direction. So this will be just tension minus tension equals to MA r double dot of A minus omega square, and this not theta is r. Sorry, just write. Sometimes when you write, even if you remember it, you can make a mistake. So this is the case for using equation for this. Now if I do a similar equation for, let's see, if I do FB equals to MB AB, and if I look at that guy, this is the origin, tension is pointed towards the origin on this guy, this is on B, and so its equation will be again minus T equals MB RB double dot minus omega over RB. And it seems like we didn't make much progress. We can make this equal to that and that can be equation with a whole bunch of unknowns here. We just need this. This is okay. If you look at the problem, I got all, and then these guys are all the B quantities. I need to get rid of those B quantities. So how do we get rid of the B quantities? When we look at it, you have a RA here and RB here. That's equal to the total length of the string. So you have a RA plus RB equals the total length. That just says that these can be converted into each other, okay? And can solve the problem. So if I take it one derivative, RA dot plus RB dot equal to 0, that I don't need this one to another derivative, RA double dot plus RB double dot equal to 0. Now this one I can use here and convert that to RA, and I can use this guy to convert into over here. So let's do the algebra. All right, we got the algebra now. So we have MA RA double dot minus MA omega square RA was equal to MB R double dot is minus RA double dot, and this is minus MB omega square. This is L minus RA. Of course, these guys bring it together. So we have MA plus MB RA double dot and everything else on the other side. So you have MA omega square RA, MB omega square RA, this minus becomes plus, this becomes a plus. So if you look at this omega square part, I get MA RA from here, I get MB RA from here, and I got minus MB omega square L. I hope not making boo-boo here. So this is going to be this whole thing in the numerator and this whole thing in the denominator. And that would be the answer. Pretty cool, actually. This problem, going back, let's look at some reason this problem could be hard. One is, of course, this problem is doing polar coordinate, and polar coordinate is notoriously hard. And another is like there is a situation before t equal to 0 and there's a situation after t equal to 0. So there's one problem here for polar, and this is second problem that you have to pay attention to. And the third one is this constraint. So this is constraint, because you can get over here and then get stuck. You can get stuck over here because you are kind of in t less than 0 mode, but somehow you manage to get beyond the t greater than 0 mode and just immediately after t equal to 0. So we're looking at situation t equal to 0 plus in a calculus language, okay? So when doing that, and I think you can get up to here, then you can get stuck there, and then you gotta discover this one to actually solve it. But once you are fine with this, there's quite a few problems I've seen which are kind of built onto this problem. So this is a very good building block of a whole bunch of other problems. So I'll suggest you go over this. I think this is more suitable to the engineering tests than the medical tests. But if you're a little bit more advanced student who's trying to compete for good medical school, you might benefit from this problem. Take care. Bye.